behind every successful man there is a woman. But it is also true that behind every successful scientific conference there is a businessman. Now, when you look into this kind of a picture, our eyes and our heart is filled with admiration, amazement, and astonishment. Wow, what a myriad of stars assembled at one place. You get Heisenberg, you get Einstein, you get Niels Bohr, you get Marie Curie, you get Lorentz, and you get a myriad of great scientific people assembled at one place. Perhaps this is considered to be one of the most intelligent picture ever taken. But have you ever thought that who was the person who made this superhuman effort to bring one of the best brains in the world together? Who was the person? How did it happen? What was the conference about, and how these discoveries about those conferences, what were the talks? We never thought on that angle, or maybe we have done. The Solvay Conference has been devoted to some of the outstanding open problems in both physics and chemistry. They began with a kind of a historic invitation kind of a model which took place in 1911 Solvay Conference, and since then it is still continuing in 2022 and 2023 also. So in this 1911 Solvay Conference, it was a turning moment. It was a moment which entirely turned the entire history of physics and chemistry in terms of getting people around. But do we really think about what has been discussed? Who was the person, most importantly, who took this effort in getting those people together? Yes, I am talking about the Solvay Conference, and in this video I would be taking you through a wonderful, fascinating and an educative tour into the Solvay Conference, how it started, who was the person, who were the people who were invited, what were the discussions that took place, and most importantly, what are the most eminent and important discoveries made by these people. My name is Shaunak, and you're watching this video on my channel Physics for Students. Wishing you all a very happy new year and a warm welcome to a kind of a fascinating tour into Solvay Conference, discoveries, inventions, and the great person behind this conference who made it possible. Let us find it out in our today's video.
Solvay conferences are extremely important in our current understanding of physics, mathematics, and especially quantum theory. In today's video, we would be taking a tour on those Solvay conferences, understanding the outcome, the importance, and how they were formed, and who are the major contributors in those conferences, who were the scientists, and what are the major contributions. We are also going to look into the formation of Solvay conferences, which are very, very important and central in our understanding of classical theory and thereby evolving into quantum mechanics. My name is Shaunak, and you're watching this video on my channel Physics for Students. A warm welcome, and let us go and take a dive into the Solvay conferences, how it has been formed, and what are the major outcomes, framing our understanding of quantum mechanics. So before we go ahead, let us see what are the topics that we are covering today. We are covering, first we will understand what is a Solvay conference, who was Solvay, how the creation of the Solvay Conference happened, the first Solvay Conference, who were the participants, why was it conducted, the scientists and their major contributions, the importance of first Solvay Conference, and then we move on to second Solvay Conference, the participants, the third Solvay Conference, their participants, the fifth Solvay Conference, and the journey that continues till date. So first we look into what is a Solvay Conference. Now, the Solvay Conference actually is devoted to outstanding preeminent open problems in both physics and chemistry. However, we are looking into physics right now. So they began with the historic invitation-only model in 1911 Solvay Conference on Physics, considering a turning point in the world of physics and continuing till present day. Followed by the initial success of 1911, they have since been organized by the International Solvay Institutes for Physics and Chemistry, founded by the Belgian industrialist Ernest Solvay in 1912 and 1913 and located in Brussels. The institute coordinate conferences, workshops, seminars, and colloquia. Recent Solvay conferences usually go through a cycle of 3. The Solvay Conference on Physics, followed by a gap of year, and followed by the Solvay Conference on Chemistry. So this is the first understanding of what actually is a conference. It's a conference which deals with a lot of problems in physics and mathematics, chemistry, and thereby scientists come and get a chance to discuss. But before that, the most important part is that who pioneered this and who was the basic founder of all those conferences. Ernest Gaston Joseph Solvay was a Belgian chemist, industrialist, and a philanthropist. He was born in Rebec and he was prevented by his acute syndrome of pleurisy from going to university. He worked in his uncle's chemical factory from the age of 21. In 1861, he, along with his brother Alfred Solvay, developed the ammonia soda process for the manufacturing of soda ash from brine and limestone. He founded the company Solvay and Cy and established his first factory at Cowlit in 1863 and further perfected the process until 1872 when he patented it. Soon Solvay process plants were established in the United Kingdom, US, Russia, Germany and Austria. Today, about 70 Solvay process plants are still operational worldwide. The exploitation of these patents brought Solvay considerable wealth and money, which he used for philanthropic purposes, including the establishment in 1894 of the Institute for Sociology at the Free University of Brussels, as well as International Institute for Physics and Chemistry. In 1903, he founded the Solvay Business School, which is a part of the Free University of Brussels. In 1911, he began a series of important conferences in physics known as the Solvay Conferences, whose participants included Max Planck, Rutherford, and other eminent scientists. Before we go ahead, let us understand some quick unknown facts of this gentleman. Ernest Solvay wanted to sell his chemical process, but his original patent was invalidated, so he had to create his own company to exploit it. His first job was at gas works owned by his uncle, but he spent most of his time working on personal projects. His uncle eventually fired him, and it gave him a chance to launch Solvay and Cy. With political views combining liberalism and socialism, he declared that society is obligated to strive for social justice or else it will die, and supported total equality for all. A major patron of sciences, he was curious, especially about radioactivity, and financed a series of Marie Curie's projects. An enthusiastic of mountain climber, he financed the construction of the Solvay Refuge on the Matterhorn in Switzerland. These are some of the unknown facts of this great gentleman who ultimately culminated in creating Solvay and thereby beget those eminent scientists and changing the course of science and history. But before we go ahead a little bit more, we need to understand how this wonderful company Solvay was created. If you go to internet, you can type out the name and you will get the website also. So Solvay is basically a science company whose technologies bring benefits to many aspects of daily life. As a global leader in materials, chemicals and solutions, Solvay brings advancement in planes, car batteries, smart and medical devices, water and air treatment. Now, brothers Alfred and Ernest Solvay, as you can see on the illustration photograph, were just 23 and 25 years old respectively when they founded their company in 1863. Here the brothers, Alfred II and Ernest III from the right, are depicted alongside management colleagues visiting the company's violent soda ash plant based in Germany in the late 1880s. Solvay pioneered the heavy chemical industry in numerous countries, including the United States in 1881. Now, the Syracuse, New York plant, the first in the US to manufacture soda ash, was located in the town who would eventually be named after Solvay. Ernest Solvay called science his fifth child. Though pleurisy kept him out of the university, after amassing fortune, Ernest devoted time and money to endow into scientific learning. As you can see in the photograph here, several institutes are depicted from left to right. Physiology, 1895, then the business school in 1903, and sociology in 1902, all part of Scientific, set up in Brussels at Parc Leopold, nearby today's EU institutions. Ernest Solvay cherished physics most, so he funded in Brussels a series of councils bringing together the era's most brilliant physicists. The first one was held in 1911, which gathered Einstein, Curie, Langlois, Nernst, Planck, Broglie, Lorentz, Rutherford, Ari, Poincaré, and others. A similar council of chemistry was held in 1922, and institutes has since been created to organize such meetings on a regular basis until even today. Now, this is the time we should know that how the first Solvay Conference really came into being and how it was formed. Now, as you can look into this hotel, this is called the Hotel Metropole today. This was the venue where the first 1911 first Solvay Conference was being held. And this is a kind of a postcard from 1920. Now, in his invitation letter dated 15th of June 1911, Ernest Solvay explained that he conceived the first meeting as an international scientific council to elucidate some current questions of molecular and kinetic theories. Hendrik Lorentz was chairman of the first Solvay Conference on Physics held in Brussels from 30th October to 3rd of November 1911. The subject was radiation and the quanta. This conference looked at the problems of having two approaches, namely classical and quantum theory. The first Solvay Conference is considered a turning point in science when classical physics was about to give way to quantum theory, forever changing the field. So this is the name of the first conference, Radiation and the Quanta. Now, as you can see, the first conference, which consisted of 24 participants, all of them are invited through, all of them are basically invited. So Ernest Solvay himself was not present when this group photo was taken. That is why you see his head appears noticeably larger than it ought to. This portrait was crudely pasted on before the picture was released. So there may be a stand-in for Solvay when the photo was shot, and whoever did this clumsy doctoring made absolutely sure that Solvay's head was larger than the face it had to hide. Albert Einstein was then the youngest in attendance, as you can see in the picture. Although Louis de Broglie was not among the invitees, he did accompany his older brother Maurice de Broglie, who was acting as a scientific secretary. Legend has it that the 1911 Solvay Conference helped Louis de Broglie decide to start a career in theoretical physics. He would become one of the rising stars at the Solvay Conference of 1927. Now, once we look into this picture, let us take a quick look into who were the invitees, who were invited, and Hendrik Lorentz being the chairman. And when I tell invitees, I mean to say those who were invited, and we will soon find some of the eminent physicists whose photographs are there, yet they're not invited. What is the reason? So we first start with Germany, and we find Nernst along with Max Planck, H. Rubens, Sommerfeld, W. Wien, and Emil Warburg. These are the 6 people from Germany. And then we go to the next country, which is England. Lord Rayleigh, although he didn't came for the conference, followed by Rutherford and J.H. Jeans. Then comes France, which is Maurice Vrillon, followed by Madame Curie, Paul Langlois, followed by Jean-Baptiste Perrin, followed by Henri Poincaré, and then we move to the next, Austria, the famous Albert Einstein, followed by Friedrich Hassenauer. Holland was only H. Kamerlingh Onnes, followed by Van der Waals, who did not attend the seminar. And then in Denmark, we find the famous Martin Knudsen. Now, these were the invitees, but we also find Lindemann and Robert Goldschmidt, and they were appointed as secretaries, followed by G. Hostelt and Eduard Herzen. They were co-workers with Ernst Solvay. So this is the famous photograph taken at that famous hotel at Metropole, and this hotel carries the kind of a legend that these people were there. So let us see if we can identify those people. We start with Ernst, who is basically the pioneer in organizing this Solvay Conference. Then we find Vrillon, followed by Solvay, although he was not present. Henry Ganton Lawrence, followed by Warburg. And then we get this gentleman, who is Jean-Baptiste Perrin, followed by Bien. And then sitting right down with her hand on his head is Marie Curie, the only woman, and followed by Henri Poincaré. And then we go back to R. Goldschmidt, and you can understand who is Max Planck, the father of quantum mechanics, followed by H. Rubens, Arnold Sommerfeld. Then we go to F. Lindemann, and here is Maurice de Broglie. The next is M. Knudsen. We standing right there is Friedrich Hassenol. Then the G. Hostel, and then we find E. Herzen, followed by J. H. Jins, the Englishman, followed by Rutherford, Ernest Rutherford, and H. Kamerlingh Onnes, and then our favorite dear old Albert Einstein, followed by Paul Langevin. So these are the 24 participants who took place, followed by an invitation, and it entirely changed the course of physics. How? Let us find it out in the next part of our video. But before we go ahead, first we need to understand why this Solvay conference was conducted. What was the reason? See, Walther Nernst, the German chemist and physicist, was the principal architect of the first Solvay conference. Nernst, then director of the Second Chemical Institute at the University of Berlin, contacted Ernest Solvay through the good offices of one of the ex-students, the Belgian Robert Goldschmidt, with a proposal to invite a selected group of physicists around the world to an international conference devoted to debating the new theories of physics and attempting to reconcile molecular kinetic theory with Planck and Einstein's quantum approaches to energy and radiation. Okay, so Nernst also saw the debate on quantum theory as an opportunity to confirm what he was researching, his third law of thermodynamics, introduced in 1905. So Nernst was actually doing experiments on thermodynamics as well as quantum theory, at very low temperature, and his results were confirming some of the thoughts already expressed by Planck and Einstein. Now, Walther Nernst actually thought that he might win a Nobel Prize. His apprehension was that, but in order to do that, because it was quantum theory and it was not yet accepted by many celebrated physicists, he thought to bring all the great physicists around the world to a common platform where he can discuss and show his results. He was very enthusiastic in bringing together the scientific community, and the opportunity to present her own ideas in physics was also there. As I have been telling, that it was basically an attempt to reconcile and discuss more on the classical and the quantum mechanics. So Walther Nernst, remember, was basically the architect of this first Solvay conference. He pursued Solvay in order to get a funding, gather all those people, come on a common platform, as well as there was an internal motto because his results should confirm with the thoughts of Planck and Einstein, who were already working on quantum mechanics. So this was why the first Solvay conference was done. We will soon find out what are the results of that. But before that, what is important is that who were the scientists and what are their contributions in terms of the first Solvay conference and their own work. So we start with Walther Nernst, a German chemist known for his work on thermodynamics, physical chemistry, electrochemistry, and solid-state physics. His formulation of the Nernst theorem helped pave the way what is called now the third law of thermodynamics, for which he won the 1920 Nobel Prize in Chemistry. He is also known for developing the Nernst equation in 1887. In 1905, he proposed this new theorem, later known as the third law of thermodynamics. He showed as the temperature approaches absolute zero, the entropy approaches zero, while the free energy remains above zero. And this is the work for which he is best remembered for. Okay, so we move on next to the French physicist Marcel Vrillon. Now, Marcel Brillat was a French physicist and mathematician. In his long career, Brillat published more than 200 papers and books. He was a great admirer of Calvin's lectures and wrote a preface and notes for their translation. He also provided a notes for a book of translation of original papers of meteorology. His interest in the kinetic theory of gases, liquids and solids is reflected in his contribution of a preface and many notes to the French translation of Boltzmann books. There followed a series of important papers on Helmholtz law and surfaces of discontinuity with applications to hydrodynamics. So this is a kind of, and he also worked on the theory of times. We move to the next person, very familiar face, Hendrik Anton Lorentz, a Dutch physicist who shared the 1902 Nobel Prize in Physics with Peter Zeeman for the discovery and theoretical explanation of the Zeeman effect. He derived the Lorentz transformation, which Albert Einstein subsequently used to make claims to special theory of relativity, as well as the Lorentz force. Lorentz was also responsible for the Lorentz oscillator model, a classical model to describe the anomalous dispersion observed in dielectric materials. Coming up next is the German physicist Emil Warburg. He was a German physicist, and during his career he was a professor of physics at the University of Strasbourg. At Strasbourg, Warburg and Kundt actually collaborated on two famous studies on the theory of kinetic gases. In 1875, they furnished conclusive experimental confirmation of a consequence that Maxwell had derived from his theory, that the inner friction and the heat conduction of a gas are independent of the pressure. Very important. Are independent of the pressure so long as the mean paths of the molecules are negligible with respect to the dimension of the container. They extended their investigation to very rarefied gases and deduced from the theory the existence of a measurable slipping and of a jump in temperature at the container wall. They also demonstrated the existence of measurable slipping measures experimentally. Okay, so we come another French physicist, very important and famous, Jean-Baptiste Perrin. Now, Jean-Baptiste Perrin was a French physicist who, in his studies of the Brownian motion of minute particles suspended in liquids, verified actually Albert Einstein's explanation of the phenomena and thereby confirmed the atomic nature of matter. For this achievement, he was honored with the Nobel Prize in Physics in 1926. In 1919, Perrin proposed that nuclear reactions can provide the solar source of energy in stars. He realized that the mass of a helium atom is less than of 4 atoms of hydrogen, and that of mass energy equivalence equal to mc square of Einstein implies that the nuclear fission could liberate sufficient energy to make stars shine for billions of years. So he mostly is remembered for his immense contribution and experimental verification of mass energy equivalence as well as the Brownian motion. So William Carl Wien, actually a German physicist who in 1893 used theories about heat and electromagnetism to deduce what is called Wien's displacement law, which calculates the emission of a black body at any temperature from the emission at any one reference temperature. He also formulated an expression for the black body radiation, which is correct in the photon glass limit. His arguments were based on the notion of adiabatic invariance and were instrumental for the formulation of quantum mechanics. Wien received the Nobel Prize in 1911 for his work on heat radiation. Who could forget this wonderful lady, Marie Curie, a Polish naturalized French physicist and chemist who conducted pioneering research on radioactivity. She was the first woman to win a Nobel Prize, the first person and the only woman to win a Nobel Prize twice, and the only person to win a Nobel Prize in 2 scientific fields. Her husband Pierre Curie was a co-winner of the first Nobel Prize, making them the first ever married couple to win Nobel Prize and launching the Curie family legacy of winning 5 Nobel Prizes. Under her direction, the world's first studies were conducted into the treatment of neoplasms by the use of radioactive isotopes. She founded the Curie Institute in Paris in 1920, and Curie Institute of Warsaw in 1932. While a French citizen, Marie Curie, who used both surnames, never lost her sense of Polish identity. She taught her daughters the Polish language and took them on visits to Poland. She named the first chemical element she discovered polonium after her native country. Henri Poincaré, a theoretical physicist, engineer, and a French mathematician. He is often described as a polymath and in mathematics the last universalist. As a mathematician and physicist, he made many original fundamental contributions to pure mathematics and applied mathematics and celestial mechanics. In his research on three-body problem, Poincaré became the first person to discover a chaotic deterministic system which laid the modern foundation of what we call as chaos theory. He also considered to be one of the founders in the field of topology. We come next to Robert Goldschmidt, a Belgian chemist, physicist and engineer who first proposed the idea of standard microfilm. Goldschmidt was a polymath who also made advances in aviation and radio and among other fields. Remember, in 1913, he constructed a major radio facility at Belgium, where in 1914, he and Raymond Brillard inaugurated Europe's first regular radio concert broadcasts. Well, you can understand him to be the father of quantum mechanics. Max Planck, a German theoretical physicist who discovered energy quanta and which fetched him the Nobel Prize. Planck made substantial contribution to theoretical physics, but his fame as a physicist remained mainly on his role as the originator of quantum theory, which revolutionized human understanding of atomic and subatomic process. In 1948, the German scientific institution Kaiser Wilhelm Society was renamed Max Planck Society. The Max Planck Society now includes 83 institutions representing a wide range of scientific directions. We move next to Arnold Johannes Wilhelm Sommerfeld, a German theoretical physicist who pioneered developments in atomic and quantum physics and also educated and mentored a lot of students for a new era of theoretical physics. He served as a doctoral supervisor for many Nobel Prize winners in physics and chemistry, introduced the second quantum number, which is the azimuthal quantum number, and the third quantum number, the magnetic quantum number. He also introduced the fine structure constant and pioneered X-ray wave theory. Martin Hans Christian Knudsen, a very famous Danish physicist who taught and conducted research in the Technical University of Denmark. He is primarily known for his study of molecular glass flow and development of Knudsen cell, which is primary component of molecular beam epitaxy systems. Knudsen was renowned for his work on kinetic molecular theory. His name is associated with Knudsen flow, Knudsen diffusion, Knudsen number, Knudsen layer, and Knudsen gas. Okay, so Friedrich Hassenall is basically known for cavity radiation. I won't be speaking too much about Friedrich Hassenall. The reason is that I have made a complete video on Friedrich Hassenall, the unsung physicist from Vienna. If you want, you can go to my playlist on biographies and quickly have a look on that. Here comes the British gentleman, Sir James Hopwood Jeans, was an English physicist and astronomer. James Hopwood Jeans actually made contributions in calculating the rate of atmospheric escape from a planet due to kinetic energy of the gas molecules, a process which is known as Jeans escape. He also helped to discover the Rayleigh-Jeans law. The New Zealander Ernest Rutherford, first Baron Rutherford of Nelson, was a New Zealand physicist who came to be known as the father of nuclear physics. Britannica considers him to be the greatest experimentalist since Michael Faraday. Apart from his work in homeland, he spent a substantial amount of his career in both Canada and United Kingdom. In his early work, Rutherford discovered the concept of radioactive half-life, the radioactive element radon, and differentiated and named alpha and beta radiation. This work was performed at McGill University in Montreal. It is the basis for the Nobel Prize in Chemistry awarded in 1908 for his investigations into the disintegration of the elements and the chemistry of radioactive substances. In 1904, he was elected a member of the American Physical Society. And then we come to the last but the most important person, Albert Einstein, German theoretical physicist, widely acknowledged to be one of the greatest and most influential physicists of all time. Einstein is best known for developing the theory of relativity, but he made immense contributions to the development of the theory of quantum mechanics. Relativity and quantum mechanics are the two pillars of modern physics. His mass energy equivalence E equals to mc squared, which arises from relativity theory, had been dubbed the world's most famous equation. His work is also known for influence on the philosophy of science and received 1921 Nobel Prize for his services to theoretical physics and especially the discovery of the photoelectric effect. His intellectual achievements and originality resulted in Einstein, which becomes synonymous with genius, and Einsteintanium, one of the synthetic elements in the periodic table, was basically named at his honor. So we now have covered the major scientists, although not everybody, major scientists of the first Solvay Conference, and now it is time that we should understand the importance of the Solvay Conference. Now when we talk of the importance, the first thing that we need to understand that it was a very small conference of just 24 participants held in the Hotel Metropole in Brussels. But what is important is that we should understand that Albert Einstein's paper, which was published in 1905 on special theory of relativity and others, the Brownian motion, it was only in German. So meeting people from England, Holland, Netherlands, France, etc. made Einstein more popular on the first occasion to a non-German speaking populace or speaking people. This is also important because it's the first time that classical physics and quantum theory were discussed right on the table. The duality of wave and discrete packet, all those things which quantum physics was about to bring and make a complete change in human understanding of subatomic realm, was first discussed in the first Solvay Conference. It was a turning point for modern physics because modern physics before that have never ever encountered quantum mechanics, and quantum mechanics along with Einstein and others were discussed up front. This was the first time that Albert Einstein made a companionship and a lifelong friendship with Marie Curie, and it continued for a very long time. And Einstein was actually willing to go back to Zurich, and he required a kind of a recommendation letter which was given by Curie, Marie Curie, discussing and telling on the brilliance of Albert Einstein so that he can secure a job at Zurich University. Also, the companionship resulted into the problems of the French press, where Marie Curie's liaison with Paul Langevin created a lot of problems, and Einstein actually wrote that, "Do not worry, Curie, this is something which you are beyond the controversies with Langevin." So that was the culmination point, a very important friendship which continued lifelong. And it was also important because the industrialist Ernest Solvay, who gave 1,000 francs to each of the scientists, made it a decision that he would be continuing this education, dispersing certain funds and amounts further for the enhancement of science, physics and mathematics. So Solvay's decision for sponsorship, followed by Ernst, was actually the key culmination point. So first was that the Einstein's paper was made popular to a non-German community. The classical physics quantum theory, first time brought into the play, were discussed at length. The duality of wave and particle of nature was first discussed on the table. People came to know. Quantum theory came right in front, and Curie and Albert Einstein's friendship continued for a long time. Most importantly, Ernst Solvay's decision of sponsorship and carrying it further actually sealed the foundation of the Solvay Conferences. So the second Solvay Conference, which took place, now this is actually the photograph of second Solvay Conference, and you can see that the venue has changed from indoor to outdoor. So these are the scientists who were present in the second Solvay Conference. We'll quickly try to look into some of them. So we start with this gentleman, the architect Ernst, followed by Rutherford and then Wien. And here for the first time we see J.J. Thomson. So you can see and understand that quantum mechanics is already on the roll and people from quantum physics are now participating in Solvay Conference, followed by E. Warburg, Henry Anton Lorentz, followed by M.L. Vrillon. These are the scientists who have been standing right at the back. We will just take a quick look, not covering everybody. Friedrich Hassenall, then the English gentleman, Jeans was there, followed by Marie Curie, Albert Einstein, and then standing is F. Lindemann, Maurice de Broglie, W. J. Pope, E. Grunsen, M. Knudsen, G. Hostel, and P. Langlois. The third Solvay Conference was held in April 1921. The reason is that soon after World War I, there was a gap. So most German scientists were barred from attending in protest of this action. Albert Einstein, although he had renounced German citizenship in 1901, had become a Swiss citizen, declined his invitation to attend the conference and publicly renounced any German citizenship again. Because anti-Semitism had been on rise, Einstein accepted the invitation by Dr. Chaim Weizmann, the president of the World Zionist Organization, for a trip to the United States to raise money. So this was the venue of, this was the third Solvay made at a gap because the First World War was going on. We will again try to take a quick look on the members of that, and this is the first time Albert Abraham Michelson, right? Remember that he was the first American physicist to win the Nobel Prize. We find Weiss, followed by Martin Knudsen, and then we find Vrillon, followed by Langlois, and Ernest Solvay was present very much. So Paul Langlois was there. Now, I would like to tell you something, that Paul Langlois is actually developed what is called Langlois dynamics and Langlois equation. He was a doctoral student of Pierre Curie and later a lover of widowed Marie Curie. We find Ernest Solvay, Henry Anton Lorentz, Ernest Rutherford, Robert Andrew Millikan, and Marie Curie. We find Maurice de Broglie. Now, de Broglie actually made advances in the study of X-ray diffraction and spectroscopy. During the First World War, he worked on radio communications for the Navy. Let us see who are the gentlemen standing right at the back. Okay, so we got Sir William Lawrence Bragg, an Australian-born British physicist and X-ray crystallographer, discovered 1912 of Bragg's law of X-ray diffraction, which is basic for the determination of crystal structure. Very important. He was a joint recipient with his father, William Henry Bragg, of the Nobel Prize in Physics in 1915. Here is Van Obel, Johannes T. Haas, and then we find Herzen, Charles Grover Blacker, and Paul Ehrenfurst, an Australian theoretical physicist who made major contributions in the field of statistical mechanics and its relation with quantum mechanics, and he was a close associate with Albert Einstein. Now we come to the most important and the celebrated fifth Solvay Conference. Now it was this, as far you can put up your comments actually. The most famous conference was held at this place. Fifth Solvay International Conference was basically held on electrons and protons. The world's most notable physicists met to discuss the newly formulated quantum theory from 24th to 29th of October 1927. Einstein, disenchanted with Heisenberg's uncertainty principle, remarked, "God does not play dice," and Bohr replied, "Einstein, stop telling God to do." This fifth conference produced the greatest of minds ever, and what most probably is the most intelligent picture ever taken. It is hard to imagine a more brilliant group of people in the same room together. 17 of the 29 attendees were or would become Nobel Prize winners, including Marie Curie, who alone among them had won Nobel Prize in two separate scientific disciplines. So as far as my research go, I mean to say, you can always correct me. I'm open for suggestions. This is the address, and this is the place where that famous iconic picture, the most intelligent picture, was taken. This is, I mean to say, this is my idea, because I tried to make through the landscape, etc. So I won't be going ahead to explain this particular photograph because almost all of you know who are those people. So that is how the 5th Solvay Conference takes place. Great pictures come along of Albert Einstein, followed by Bohr and Max Planck. Here you see Heisenberg. Everybody, I mean to say, every single great person, followed by Pauli, and then Marie Curie, followed by Schrödinger and Pierre Cardi. Everybody follows. But as you see, that 5th Solvay Conference was started, and it was considered to be one of the pioneering conference because almost all the great physicists around the world was present. And the inception was on the 1st Solvay Conference. And from here we take on the journey further. It started in this small room with 24 participants, and then it went on to 1913, 1921, followed by 1927, 1930, and then we come to the era of 1933. We turn the pages of history and we find 1961, 64, 67, and then we slowly turn into the colored era of 2014, 17, and so on. So it continues, and it still continues with the upcoming dates of the 29th Solvay Conference on Physics, which is to be held on 2023 between 19th to 21st of October, and the topic being the structure and dynamics of disordered systems. So that's all. This is a kind of a tour to make you understand about Solvay conferences, how it formed, who were the people, the major contributors, the scientists, the background behind that, and the one great gentleman, Ernest Solvay, who made this all possible. Thank you very much for watching this video on Physics for Students. I hope you liked it, and please put up your comments and subscribe for my channel. Click on the bell icon and click on all notifications so that you get all the notifications on physics and mathematics from Physics for Students. This is Shaunak signing off right now, promising you to be back with yet another interesting video. Till then, goodbye, stay happy, and continue learning physics and mathematics. Bye-bye.
Thank you for watching this video. We appreciate your time and patience. If you want to connect with us and provide further feedback, comment, or suggestions, please email us at contact.physicsforstudents@gmail.com. You can also follow us on Facebook, Instagram, and LinkedIn. See you soon in the next video.